Hey, third grade, this is your math video for lesson 6.3. So today for this math lesson, we are just going to briefly review some multiplication strategies. So in our previous unit, we have learned a lot of different ways: doubling, near squares, break apart strategy, adding a group, subtracting a group. So sometimes when you have so many strategies, they can get a little confusing, or you might mix them up sometimes. So we're gonna kind of look at a few of the different strategies and go from there. So we're going to start with our math message. With this one, we are going to be working on our whiteboards. I don't believe we'll need our workbooks. All of your work will be on your whiteboards or a piece of paper. So pause the video while you get your materials. So our math message today is: Evan does not know the answer to 6 times 7. Record on your whiteboard at least 2 different strategies he could use to solve 6 times 7. So like I said, we have near squares, doubling, break apart, adding a group, subtracting a group, any of these strategies that you want to use to solve 6 times 7. So I want you to pause this video while you try to create 2 of those strategies on your whiteboard or piece of paper. Once you have those 2 strategies, you can start the video again and we will go over some of them. All right, so solving 6 times 7. What are some ways that Evan could do this? Well, he could add a group. So that would look like, well, he knows the fact. So his helper fact is 5 times 7, which equals 35. So he would need to add a group of 7, though, to that total. So that's where the adding a group comes in. So he would do 35 plus 7 would equal 42. So 6 times 7 equals 42. So check your work. Was this one of your strategies you used? Another one he could use is doubling. So he could break the 6 apart, which would be the doubled fact, and do 3 times 7, which equals 21. And then he would do 3 times 7 again, which also equals 21. So then he would add 21 plus 21, which would equal 42. So again, 6 times 7 equals 42. We'll talk a little bit more about doubling later on in this video. Another one he could do is a near square. So he could do 6 times 6, which equals 36. And then he would need to add another group of 6. So he could do 36 plus 6 would equal 42. Now, you could also go up to the near square of 7 times 7 and do it that way. But in that case, you would have to subtract from your total since it's greater than 6 times 7. But both would get you to 42. And the last one he could look at would be a breaking apart strategy. So 6 times 7 could be broken apart into 6 times 5 plus 6 times 2. So 6 times 5 is 30. 6 times 2 is 12. Oh, my numbers are backwards there. There we go. 12. And then his total would be 42 because 30 plus 12 is 42. So I want you to look at your strategies that you picked and then compare them to the strategies that I shared here. You want to look at, so this next part is, what strategy should I choose? So on this slide, we saw 4 different ones, but you want to pick a strategy that is quick and easy for you to solve. So if one of these strategies takes you a little bit longer to figure out, that might not be the most efficient strategy for you. So you want to pick one that is easy for you, is quick for you, and what strategy works for you may be different from the person next to you or me. It's what works for you. Now, when I look at doubling a little bit closer, doubling is a strategy that you can't use for every fact, and here's why. So it said, could we use the doubling strategy to solve 9 times 7? The answer is no. Doubling will not work because neither factor is a double or an even number. So I can't split 9 equally in half. I can't split 7 equally in half. So for this, what other strategy could we use? So I want you to think about that. On your whiteboard, pause the video and try on your whiteboard to solve 9 times 7 using something other than the doubling strategy. All right, let's look at some examples. So we could do subtracting a group. So if I have 9 times 7, I could say, oh, well, my helper fact that's close to it is 10 times 7, which I know is 70. And then I would do 70 minus 7, taking away a group of 7. would be 63. So 9 times 7 is 63. That was a pretty quick one for me because I know 10 times 7 like that. It's a quick fact. Then you have the breaking apart strategy. So 9 times 7, well, I could break it apart into 9 times 5 plus 9 times 2. So I broke apart the 7 into 5 and 2. 9 times 5 is 45. 9 times 2 is 18. 45 plus 18 would be 63. Again, you pick the strategy that makes sense to you. Personally, I think for this one, the subtracting a group was a little bit quicker for me because I knew this fact. Where with this one, with breaking apart, you had to solve more facts and it involved a little bit more steps. But again, I want you to pick the strategy that works best for you. So now what we're going to do on our whiteboards is we're going to solve 3 problems together. One will be practicing doubling, one will be adding a group, and one will be near squares. So what we're going to do is we're going to solve 4 times 7 using the doubling strategy. So remember, the number you have to break apart is the number that is the double. So in this case, it would be 4. So on your whiteboard, break apart 4 times 7 to use the doubling strategy. Pause the video while you work through that. All right, so let's see how it looks like if we solved it. So if I break apart 4 times 7, it would be into 2 times 7 and 2 times 7. So 2 times 7 equals 14. 2 times 7 equals 14. That's my doubled fact. 4 is the double of 2. So then what you do is you would do 14 plus 14, which would equal 28. You're adding the doubled fact. And then 4 times 7 would equal 28. So that's what an example of doubling looks like. Remember, you have to split that even number. All right, so go ahead and erase your boards. Let's try one other fact for adding a group. So if I have 6 times 7 and I need to add a group, okay, so that means I'm going to pick a fact like 5 times, oh, I'm sorry, I said 6 times 7. I meant 6 times 8. So for 6 times 8 and we're adding a group, I'm going to pick a fact that would be lower than because I have to add a group to my total. I think that's where adding and subtracting groups can be a little confusing. So if I'm adding a group, that means I have to add a group to my total. So 5 times 8 would equal 40. And I would need to add a group of 8 in order to get 6 times 8. So I would do 40 plus 8, which would equal 48. So then I could say 6 times 8 equals 48. Okay, so when you're adding a group, that means your helper fact is a group less than your actual fact. Okay? And if you're subtracting a group, then it's the opposite. So that would be that your helper fact is greater than your fact that you're trying to solve. All right, go ahead, erase your boards one more time. We have one more problem we are going to practice together. So 8 times 9, and we are going to use the strategy near squares. Near squares. So on your whiteboard, there's 2 possible ways you could do this. So I want you to pick a near square, a square fact that is near 8 times 9. Okay. And then once you've solved that for 8 times 9, go ahead and start the video again. So for this one, I picked 8 times 8, which equals 64. Then I would know that I needed to add another group of 8. So 64 plus 8 would equal 72. So 8 times 9 would be 72. So for this one, I used the square fact 8 times 8 and I added a group. You could also use the square fact 9 times 9 and subtract a group, but they would both get you 72. My advice for this one is just which fact did you know? Did you know 8 times 8 or did you know 9 times 9? And that's how you can kind of use that square fact to help you solve for your other fact. All right, so like I said, we had a lot of strategies that we looked at. We did adding a group, doubling, near square, break apart, and subtracting a group. So those are what you want to use as you move forward. And eventually, actually, in our next lesson, you'll learn about what it means when you just know a fact like that and you don't need any of these other strategies. So thank you guys for watching.